Thank you very much, Professor Peck. It was really a nice introduction to me. Well, the topic I have today is like this, comparison of North and South Korea, especially with these hydrological cycles. In fact, the focus is more on the water balance in both countries. You will see there were quite a dramatic change between the two. Okay, the contents of this presentation includes background and finally the conclusions. Okay, yeah, I think most of you know who they are. They are present in South Korea, and they are rulers in North Korea. Okay. He ruled North Korea for more than 30 years, and he died around this time period. And his son, Kim Jong-il, also ruled North Korea for about 20 years. Now his son, Jong-un Kim, has ruled North Korea. He was quite dramatic, like Donald Trump in US. And in fact, we usually compare the Kim Il-sung and President Park. And he was quite much contributed to the economic development in South Korea, but finally he failed at the end of his ruling period. And in fact, he prepared another dramatic economic development plan for 1990s, but unfortunately they failed and they could not increase the per capita GDP. And as you can see in this figure, so until 1980s, the GDP per capita was a bit large in North Korea. So their living standard was a bit higher than that in South Korea. Okay? But after the 1980s, so South Korea has been quite successful in developing their economies, but some kind of economic collapse has been in North Korea. So they could not increase the GDP per capita. So it's a bit decreased recently. So now the GDP in South Korea reaches around $30,000, but they still remained in this stage. And this kind of difference in economy has arised lots of another problems. One is the shortage of the fuels, especially in North Korea. So this kind of problem has increased the demand of timbers, mostly in the some small mountain areas or mounds. So some report says that the forest area in North Korea has been decreased regionally, maybe at least 10% to maximum 35% since 1990s. So this kind of changes in land cover and vegetation has introduced a quite large difference in hydrology in both countries. This picture shows how the land cover changes in North Korea, okay, as is 1980s and 1920s. So you can distinguish this figure in this picture, okay. And this the graph shows how much the forest area has been decreased since 1980s. So the maximum 30% is on average. And the right-hand side, the picture shows that the South Korea has been so successful to increase the forest area. From originally we have this kind of the shape, but now we have this kind of shapes. So from the time point around the 1980s or 1990s, the both countries, South and North, follow totally different paths, especially in hydrology and water resources. So definitely as a result of that, we can notice some kind of dramatic drought event in North Korea. So these are some examples about the drought event occurred in North Korea around 1990 and 2000. And they mentioned that the return period of the drought in this year, 2001, was about the several hundred years. And in this case, was more extreme. They say that is the drought with a return period more than 1,000 years. But you know that the Korean peninsula is not that huge. So we assume that climate in South Korea and North Korea is more or less the same. So, but during this period, we say that the return period of those drought were less than 30 years or something. It was serious, but not that serious in North Korea. So we assume that this kind of huge drought event is partly due to that kind of deforestation in North Korea, mainly because of the economic value. Okay. Now let me summarize the objective of this study. So we want to compare what has happened in South Korea and North Korea. But you know that the data, hydrologic data in North Korea is not available. Some precipitation and temperature data are available, but that is the maximum. No observation data about the runoff or soil moisture is not available at all. So we need another tool to compare the situation in South Korea and North Korea. So we decide to use the VIC model. So I will explain what this model is. And to consider the change of land cover in North Korea, we use different land cover data for every 10 years. And we use the runoff data observed in South Korea for the validation of the modeling study. Also, we compare the soil moisture data over entire Korean peninsula. That soil moisture data is collected by the satellite. So we are going to compare that. And finally, after the validation of this simulation, we are going to compare the situation in South Korea and North Korea. Okay, this slide summarizes what the VIC model is. This is a large-scale land surface model developed by the University of Washington, and they still use it. Okay, and it considers water balance and energy balance, and some kind of interaction between the soil and vegetation and atmosphere. And the VIC model has two different parameter sets. One is related with the soil, another one is the vegetation. So with some information about the soil and vegetation cover or land cover, then we can kind of automatically decide the parameters. So in the parameter estimation, we do not use any kind of trial and error or any kind of optimization techniques. So it's kind of a straightforward procedure to decide the parameter estimation of the VIC model. And the VIC represent variable infiltration capacity. So it's kind of technique to improve the quality of runoff simulation. Okay. And we set the simulation using this kind of conditions. The resolution, the spatial resolution we adopted is 0.5 times 0.5 degree. So we have 92 cells within the Korean Peninsula. So it's kind of rough simulation. And the simulation time step was set to daily. So we did the simulation during this period from 1983 to 2013, so more than 30 years. And we divide this simulation period into 3 terms, the first term and second term and third term. In fact, this division was introduced to consider land cover change. So for this period, we use one land cover information, and for this period, another one, and for this period, another information of land cover. Okay, let me explain something about some data used for parameter estimation. Well, it's not that complicated, and we use 2 different soil-related data. One is the soil classification, and another one is the soil depth. So this 2 information is really important for determine the parameter and ultimately determine the soil moisture condition, etc. So the information was provided by FAO, and that information was made in 1995. And we assume that this soil condition remains unchanged during the simulation period. And this is one result of the parameter estimation about the soil-related parameters. And as you can see in this table, there's no obvious change between north and south. So soil characteristics can be assumed more or less the same in north and south. And this is the land use data we used for estimating the parameters related with the vegetation, etc. And the first one is the data released, made in 1983. So this land cover data is used for the first term, and the second one, University of Maryland, and this was made in 1995. So is it for the second term, and another one for the third term. Originally, we wanted to collect the land cover data made from the same institute, but unfortunately, those data were not available. So we use the land cover data made by different institute. But quite fortunately, the effect of the different institute was not serious. I think you can see the result during the validation study. But as we have different land cover data, the vegetation-related parameters were a bit different from South Korea and North Korea. Also, the parameters estimated, even for the South Korea, the parameters were a bit different depending on the land cover information used. Okay? So this kind of changes were considered in the simulation, definitely. But some differences could be found, especially in these parameters. But overall, the parameters seems not so hugely different each other. But anyway, we could find some difference. And for the simulation, we need some meteorological data. One is the precipitation, and another one is the temperature, minimum and maximum. Also, this model requires wind speed. So we collect this information from WMO, and the information is available at these gauging stations. So not that many gauging stations were not used in this simulation. So it is possible to have no information for some cells in the simulation. In those cases, we extrapolated. Okay, so using the information available at this point. Okay, let's talk about some validation. Okay, so in fact, two different validation procedures were with the observed runoff data. That's for the some South Korean part, using some runoff data observed at the Soyangang Basin and Chungju-dam Basin. Okay. Another one is, as I said, with the soil moisture data observed by the satellite. And to check the validity of the land use data, so we compare the runoff data for these three periods. Each time period represents each one is land use data. Okay. So as you can see, the observed runoff data and the simulated runoff data matches quite well. It's not a perfect, but we can say the simulation result is maybe acceptable. And the correlation coefficient estimated is around 0.8, so it's not that bad. Especially the result is not that bad because the parameters were never been optimized. Okay. And this is one result based on the comparison of soil moisture, and where we use the satellite observed soil moisture data provided by ESA CCI. And the first we draw the box plot. This is for the satellite data, and this is for the simulation data, where the mean may be more or less the same, but the variability is a bit different, especially in the simulated data, where the variability of soil moisture is rather high, and some extreme values more found in the observation data. But you have to understand the difference between the two. The soil moisture data in the simulation represent the soil moisture for at least 1 meter soil depth. But in the satellite data, the soil moisture represents the maximum 5 centimeter or 10 centimeter topsoil part. So obviously, there can be some different. Also, the soil moisture data based on the satellite observation cannot consider the some vegetation effect. So especially during the summertime, when the vegetation is very dense, then the soil moisture data can have lots of errors. So that is the limitation of soil moisture. But still, we have quite similar soil moisture values. And this is the comparison of monthly mean. The top panel represented the some simulated part, and the bottom panel for the observation part. As I said, so we have large variation in the simulated soil moisture field, but more or less no variations in the some observed part. Okay, especially during summer, the difference is really obvious. Okay, but anyway, so based on this kind of observation, especially in the comparison of box plot, so the simulation result is assumed well reasonable. And as another try for validating the soil moisture field, we drive the EOF based on the CS EOF analysis. And as you know, the soil moisture is a very smooth field, which means that the first EOF can cover most of the variability of the original soil moisture field. So in this case, the same result is derived. So let me give you this table. This table shows the variance ratio explained by GCS EOF. As you can see in this case, the first COF represents most of the variability of the original soil moisture field. So in this case, comparison of the first, the comparison of the first CSUF has its meaning. Okay, and we check the two statistics. One is the pattern correlation. Another one is the normalized root mean square error, and it says that the level of the similarity of two CSEOFs are quite high, and RMSE value is also estimated very small, from 0.1 to 0.3. So based on this result, we assume that the simulation result is a bit reasonable. Okay, up to this part is kind of modeling and the validation part. Now let me show you some result. In fact, result is divided into two parts. One is the some entire North Korea and entire South Korea, and the other is we select several river basins in North Korea and South Korea. So we are going to compare these two cases. Also, the comparison was done with runoff ratio and evaporation ratio and the soil moisture. Okay, this is about the runoff. Well, and this is the precipitation I used as the input data. As you know that the runoff itself is very dependent on the amount of runoff. So based on this record, that the precipitation record, that there was no obvious trend in the precipitation in South Korea and in North Korea. So the trend were very similar. Also, the variability is a bit higher in South Korea rather than in North Korea. Up to 1990s, they have a very stable, the runoff ratio values. But after 1990s, in North Korea, runoff ratio becomes significantly increased. Even though we use different land use pattern in this part and in this part, but the increasing trend is the obvious in this case. On the other hand, in South Korea, we have still a very steady values. So we use the same soil data, we use the same land use data, but still in North Korea, they have this kind of different patterns. And this is about the soil moisture data. Quite interestingly, since 1990s, okay, the soil moisture value in North Korea is also increased. Originally, we expected that the soil moisture level will be decreased during this period, but the result was totally opposite. Okay, so we are not sure why this kind of result was derived, but still, this is the result. On the other hand, similar to the Salanov case, the soil moisture level remains almost the same in South Korea. Okay, this is the average value of the North Korea and over the South Korea. And this is about the evapotranspiration ratio. Okay, and we have totally opposite trend compared to the runoff ratio. Okay, this part is the represented for South Korea. So we assume that the evapotranspiration and this ratio is almost the same or maybe weak decreasing trend in South Korea, but it has quite huge and strong decreasing trend in North Korea. Okay. So, okay, let me give you another example. Okay, this part explains how the basin average runoff, soil moisture, and the evapotranspiration. Okay, so we select 3 river basins in South Korea and 2 river basins in North Korea. And this is the Soyangang Basin and the Chungju Dam Basin and the Andong Dam Basin. So these are one of the top 3 river basins in Korea. And we select 2 river basins in North Korea. One is the Daedonggang Basin, another one is the Cheongcheongang Basin. You may know that the Pyongyang, the capital city of North Korea, is within this Daedonggang Basin. Okay, and we assume that this is quite apart from Pyongyang, so we may be categorized by the rural area. Okay, this is the result for those river basins in South Korea and North Korea. And this is the result for South Korea. So almost the same in 3 river basins. So no obvious difference between river basins. But in North Korea, they have quite different the result. And this white dot represents the Daedonggang Basin. Okay? So we assume that in this river basin, the area of the forest area have not decreased so much. Okay? But in the Cheongcheongang area, in the rural part, so there must be some great a change in forest area. So the difference between the two is so huge compared to 3 basins in South Korea. Okay, and this kind of trend is also observed in soil moisture field. Okay, in South Korea, the soil moisture data is very steady. And in 3 basins, the values are almost the same. But in North Korea, they have totally different. And the decoupling between the two can be observed since 1990s. And this is a evapotranspiration case. So we also have similar result in South Korea and totally a different result in North Korea. So in fact, this is the simulation result based on the parameters and based on the input data for parameter estimation. But still, we could notice that something quite a dramatic change has been occurred in North Korea compared to the South Korea. It's obvious because we use the same data in South Korea and North Korea. Okay. Okay, let me summarize the research. And we did the hydrological cycle simulation in North and South Korea, and we found that there is a huge difference now between South Korea and North Korea. And we assume that that change was definitely due to the change of the forest area and the The area in North Korea is definitely related with the economic collapse, okay, since 1990s. Okay. So it's just 30 years period, but we can find that kind of huge difference in hydrological cycles between two countries. That's it. Thank you very much.